The screen is on and you can hear me. Fantastic. Okay, people will keep coming in for a minute, but I'll probably get started. So, hello, everyone. Nice to see you. Thank you for coming here. I hope this is going to be a fun way to end the first day of the conference for you. So my name is Steve, and I work on this thing, this Blazor product. So I'm on the ASP.NET team at Microsoft, and we've been developing Blazor for a couple of years now. And it's kind of released and kind of not released, but we'll talk more about that in a minute. Just so I can tailor my introduction to you a little bit, can you do a quick hands up if you feel that you know what Blazor is about? Like you've heard the big idea, okay, so almost everyone, all right. And also for my personal interest, hands up if you've actually used it or tried it out in any way. That's, all right, that's pretty much half of the people here, so that's pretty cool. So it's becoming a little bit tricky to decide how to do talks about Blazor because we're at the point now where so many people know about the basics that you can't really just do a whole talk about that. But at the same time, there's still quite a lot of people that need to catch up. So the kind of middle ground that I want to strike in this talk to set your expectations is for about the first 15 minutes or so, 10 to 15 minutes, we're going to go through some of the basic ideas like what's the point of this thing, why does it exist, what does it look like, what can you do with it? And we'll do a bit of programming in some simple cases. And then after that, for the remaining part of the talk, we'll go into some more advanced scenarios and we'll look at some future things that we haven't actually shipped yet, some cool experimental things that we're working towards so you can get a sense of where this is going. So, to start off with this little intro section, let me give you a quick history lesson. So I want you to think back in time, cast your minds back like as far as you can possibly remember to your earliest memories of like 2017 or thereabouts, and think about what it was like back then, back in those days, if you were trying to make a rich web application show up in someone's browser. Well, if you wanted it to be interactive in any way, you would have to use one of these things. So you'd be using something like Angular or React or Vue, and you would be building what is basically a JavaScript application. And maybe you think, well, you know, my code wasn't actually JavaScript back then. I was using TypeScript or Flow or something else. Well, yeah, that's cool, but that does compile to JavaScript. So at runtime, the semantics of your application are JavaScript. And that's just the way things were, and that's fine. People were very successful and they led happy and fulfilled lives with that. But it's kind of a shame if the only language that you can use is just one thing, because, you know, software is a rich world. We've got many different kinds of languages, frameworks, tool chains, and the web would be a richer place if there were more options available. And so that's why this exciting little thing came onto the scene at the start of 2017, which is WebAssembly, a bytecode format for the web. So it's a new type of code that can run in a browser. It's not JavaScript. It's a kind of bytecode that you can compile to from whatever sort of language or ecosystem you want. As long as you can compile to WebAssembly, you can run inside the browser. So back then, at the start of 2017, when this was happening, quite a lot of people started getting excited with ideas like, well, does this mean that we could run .NET inside a browser again, but this time without any sort of plugins, just in a pure standards compliant way? And I was one of the people who got very excited about that. I started doing some prototyping, and I thought, actually, yeah, there is a way that we can do this. We can make .NET applications run inside a browser. We need 3 ingredients to make this work. And the ingredients are, 1, WebAssembly, which is great because we've got that. In fact, we've had that for 2 to 3 years now. This has been shipping as standard in all up-to-date browsers, both desktop and mobile. So that's basically a solved problem. The next thing we need is some kind of .NET runtime. So what I found to my surprise and delight that without very much work, it was possible to compile a .NET runtime to WebAssembly. And once you've done that, you can load normal .NET assemblies into it and execute them inside your browser, which is amazing if the only thing you want to do is print messages to the console, which is not exactly what I wanted to do. I had slightly broader aspirations there. I wanted to build actual rich UIs, and so that needed a UI framework. And that's where this thing comes in, Blazor. So Blazor is a UI framework for .NET. It's not the ability to run .NET on WebAssembly. That's a separate thing. Blazor is a UI framework, and it can run on WebAssembly, but it can run in other places too. So if you are running in a browser on WebAssembly, then because you're already there in the browser, you can build a UI just by having Blazor call out to the DOM APIs for you. And that's just going to work. And this is the original hosting model for Blazor. It's called client-side Blazor or Blazor WebAssembly, as we call it now. That's the original type of Blazor, but it's not the only type. Because while we were doing this, we realized that we've got something pretty flexible here, and we can run your Blazor applications in other ways as well. So another thing that we could do is we could take your Blazor components and we could run them on a server in a cloud somewhere. And then when they want to render some UI into someone's browser, well, they can reach out across the internet through a real-time WebSocket SignalR connection and cause the UI to appear there inside people's browsers. And that is server-side Blazor. So we're going to be talking a little bit more in this talk about the differences between these two models and why you should pick one or the other depending on your situation. But before we really get to that, I want to start looking at some code, because we haven't done any coding yet, and I've had enough of some slides. So let's have a go at building an actual UI using the Blazor programming model. And the scenario I want to take on is budget allocation. Okay, that sounds unbelievably boring, but imagine the situation, right? The situation is this. Next week, you go back to your company and you adopt Blazor, and as an immediate result of that, you inevitably become dramatically more successful. Okay? And then following on from that, as another immediate result, you have loads more money than you ever did before, which is one of the problems that, you know, we can all relate to. And so we have to decide then, what we're going to do with all this extra money? We need to somehow give it out to all the staff as bonuses, but who gets the bonuses? How much do they get? Well, that's the budget allocation problem that we're going to solve. And this is a real-world problem. People try to build UIs to do this kind of thing. And an example of a real-world UI for budget allocation is this. So I got this picture off the internet. It's the Humble Jumbo Bundle 3, which is a snappy name. And when you buy that, you get to choose how your money gets distributed across these different budget items. So how about we try and build something like that using the Blazor programming model just now, and then we'll get a sense of what it's like to use. So I'm going to switch over to my IDE. And you can see I'm using Visual Studio on Windows here, but you don't have to do that. You can equally well use VS Code on Linux or Mac or on Windows if you want. You can use VS for Mac if you like. And I'm just going to use VS on Windows because I'm familiar with that. And this is my application. I'm going to start it up first, and then we'll look at a little bit of the code inside there. So if I run it, you'll see this may be familiar to many of you, certainly those of you who have seen Blazor before. This is pretty much the default file new project that you get when you create a new Blazor project. And it's got a few pages in it. It's got some example stuff like this button that you can click on and it counts it. An example of fetching some data from the server. And that's very well, but it's kind of boring, and I don't want to talk about it too much because I've talked about it a million times, and you can see plenty of information about this on the internet already. So what I want us to look at really is this bonus splitter page that we're going to implement. So where's the code for that then? Well, this is the project here, and let's get that out of our way. All right, so this is a Blazor application. In this case, it's a Blazor server application. So my code here is going to be running on the server, and it's going to be updating the UI dynamically over a socket connection, but you won't really be able to tell that's happening because it's very fast. But the same code would work equally well on Blazor WebAssembly. Doesn't really make much difference. Now, what have we got in here? What is the code? Well, it's a bunch of C# files and Razor files. So Razor files are the components in a Blazor application, and Blazor is a component UI framework. You build a set of components, they contain other components. It's just a big tree of components all the way down. And the one we want to work on is this bonus.razor. And you can see it doesn't have very much in there right now. The only interesting thing really we've got is this page directive that says this is the thing that will be displayed if you are at the URL bonus, and that is indeed the URL that I'm at. So that's why that markup is getting displayed. Okay, so let's put some logic in here now. Because this is a Razor file, I can put in some C# code that will run wherever my application is running. And I want to model the idea of this budget situation. So what are we going to do? Well, let's start by defining the total amount of money that we're trying to allocate. And we're going to say we'll have £1 million that we need to give out, or dollars, or whatever units of currency you like. And I need to know who are the candidates for receiving this money. So I've defined this class called budget item, which has got a name and an amount. And we're going to set up a list of them so we can model our scenario. Okay? So we want to give some money to developers, some to managers, and some to salespeople. And now I can use that to write a little bit of UI. So up here in my Razor markup, I can start writing out some normal HTML. So I'm going to have a div with class equals budget, And if I want to make a list of things, well, I can use a normal C# for each statement. So for each var item in budget items, we can emit some markup for those. And the markup that I'm going to emit is going to look like this. So for each thing, I'm going to display the name, the amount of money, which is formatted as currency with 0 decimal places, and then we'll just have this little to-do message over here. So let's run that now and see if that actually does render something. So we reload, and yes, okay. Can you still hear me okay? Yeah, okay, sounds weird to me up here. Right, so we can see we've got these 3 categories now: developers, managers, and sales. They've got no money, and we need to make an editor. And the kind of editor that we want to make, if you remember, looks like this. So we want to have these horizontal sliders. And the way we can do sliders in HTML is to use the input type equals range. Input type equals range. And if you want to use one of these, it starts at 0, and you need to specify a maximum value that it goes up to, and I'm going to say it goes up to the total budget. We can also specify the minimum increment step. So we don't need to go up in individual pounds or fractions of pounds. Honestly, we've got so much money now, we don't care about any unit that's less than £1,000 at a time. And then finally, we need to put this data somewhere. So I'm going to use Blazor's built-in bind to set up a two-way binding between this slider and the amount that's on my item, like that. Okay, let's try that out and see if we built a nice budget editor. Okay, so we've got these sliders, and it does actually update the values on our underlying model, which is cool. But it's not very cool just yet. Actually, it's pretty awful right now. It's nearly impossible to enter any specific amount of money because you see that the numbers don't even update until I release the mouse. So that's pretty terrible. Why is that? Well, that is because Blazor is built on normal web technologies, and the bind attribute here, that is by default connected to the browser's change event on that element. And if you know web programming, you may know that the change event will only fire when the user moves away from the component or when they let go of their mouse on a slider. So that's not the event I want to listen to. I want to listen to a different event, which is standard in the browser. And I can do that by saying the bind event I want to listen for is on input. Okay, so let's see what effect that has now on the UI. So now as I move these sliders, you'll see that the number now updates in real time, which is a lot better. But we've still got a series of UX problems with this. One of them is, how do I know when I've allocated all the money? Like I don't know whether that adds up to $1 million or not. My arithmetic is not that good. So let's display the amount of money that remains to be allocated. And we can do this quite easily. So in C#, we can define a property called remaining, and we'll compute that by starting with the total budget, and we'll subtract the sum of all the items that we've assigned so far. And then we can display that on the screen inside a span like this. The remaining amount is that formatted as a currency. Okay, let's see if that makes things a little better now. So we've got $1 million remaining, and as we move this, that amount goes down, so that's pretty good. But we've still got more problems. For example, nothing stops our user right now allocating even more money than they've actually got, like I've done here. So how can I stop them from doing that, make sure they don't overspend their budget? Well, I want to change the maximum value that you're allowed to assign. And what I'm going to say is, for each item, you are allowed to assign the amount that you have already assigned to that, plus, at most, the remaining amount. Okay? Hopefully that makes sense. You've already got this much, and this is how much is remaining maximally when you are editing this particular thing. So let's see the effect of that now. And I'll warn you, it's pretty weird at this point. So let's see. I'm going to give quite a lot of money to developers, because obviously they're great, and then I'll start assigning some money to the managers, and watch what happens. Okay, so if I move it right up to the end, well, okay, so it's good in the sense that I wasn't able to exceed my budget anymore, and in fact I can't even assign any money to the salespeople now because, you know, there's nothing left. But it's also like mad, because these two sliders, they appear to be in the same place, so you'd think they represent the same amount of money, but they don't. They represent different amounts because the scale factors have changed now depending on how I edited it. So what I'm going to do is a cool little trick, which is maybe hard to understand at first, but just go with me. I want to change the horizontal scale of these elements so that it compensates for the different max values that I'm assigning to them. So don't worry if you don't quite follow this code. You can think about it later and ponder on the maths behind it. It's not too bad. So we're saying the width of each item is going to be in proportion to the maximum amount that could be on that item. So even if you don't quite follow that, hopefully you'll appreciate the effect. Let's see what happens now. So as I move the developer's amount, you'll see that the remaining space on the other ones goes down now to compensate for it. So if there's only a small amount of money left, there's only a very small slider that I can set up for the salespeople, which is cool. And I quite like this as a UX because it really makes you think carefully about what you're doing. So if you decide that you need to give more money to one group, you have to think first about where you're taking it away from. So in this case, I would say, well, you know, these people at the bottom, they're not really adding any value, so let's move that down there, and then, you know, we can put it where it belongs. Okay, that's good. So we've made a pretty decent little user experience here, but there's still one problem left at least, maybe several, but at least one. And that's, what if our user is not being very smart today and they just don't even allocate all the money and they're just leaving some money on the table for no reason at all? How can we stop them from doing that? Well, let's say that we want to have a save button at the bottom of our UI. So I'm going to have a button with the caption save, and I'm not going to wire up any behavior to it. But what I will say is that this button will be disabled if the remaining amount is greater than 0. So a very simple and intuitive way of controlling the state of that button. Come back and reload, and you'll see that the save button is disabled right now. But if I allocate all the money, then it becomes enabled, disabled, enabled, disabled, enabled, and we've hopefully achieved our goals there. So we've created something that's quite a lot like this real-world example, and we've done so in pretty straightforward and intuitive code. Not very much code. The only difficult bit about it is this weird expression on style there. So I hope that gives you a sense of what the Blazor programming model looks like and how it allows you to combine normal HTML, normal DOM type features with some C#, and then we can run that wherever we want, whether it's on the server or whether it's inside WebAssembly. The other bit about Blazor that I've not really got into just yet is the fact that it's a component-based framework. So we've only been working on this one component, and I've not really shown you how we can split stuff up into lots of components and reuse them from each other. And to do that, I want to move on to a slightly bigger and more interesting example. So that previous application was running on Blazor Server. I now want to move on to a bigger scenario that's going to be running on Blazor WebAssembly. And as we do that, I'll show you some cool features that are not actually part of the framework yet, but things that we're thinking about, including in the future, and hopefully you can give us some feedback about. So what will the scenario be? Well, I thought it would be quite fun to do something that doesn't actually even run inside a normal computer at all, something that doesn't run inside a normal browser. I would like to do something that runs on a specialized bit of hardware, just for a change. And the scenario that came to mind for me was this. So how many of you have ever used one of these devices in your actual lives? Yeah, so they're not that unusual. They've been around for a few years now. This photo is from Waitrose, but I think I've also seen them in Asda, so don't worry, it's not just a middle-class thing. You can even use them if you're from up north, like me. And if you're not familiar with this, the way it works is you go into the supermarket and you're going to do some shopping, but you're an impatient person and you don't want to go to the checkout at the end because standing in line is just the worst thing that you can do. So what happens instead is you go into the supermarket and near the entrance, you see this big bank of devices and you walk over and you pick one of them up and it turns on. And then while you're going around the supermarket doing your shopping, each time you want to buy something, you scan its barcode with your scanner and the device displays a list of items that are in your trolley right now, and it shows you the price, the amount that you've spent altogether. And then when you finish doing your shopping and you're ready to go home, you don't have to go and stand in line and wait for someone to scan all your stuff. All you do now is you go over to the payment area and you scan your order onto the payment machine, you put your card in, you pay, and you walk out, and you didn't have to queue up. So that's the scenario. And what we're going to do in the next 20 minutes or so is build some of the UI that would run on one of these devices. And hopefully, as we go, I'll be able to give you a few reasons why Blazor WebAssembly would actually be a really good fit for this in the real world. Okay, so let's switch over to the application that we're going to be working on. Now, obviously, we don't have time to build that completely from scratch right now, so I've already started preparing a starting point for us here. And what have I got in this solution then? Well, I've got 3 projects in here, but ignore the test one for now. We'll get to that later. We've got the server and the client. I'm just going to start up my server. And I know that's kind of hard to make sense of, but there we go. All right, so the server, in this case, is the thing that's responsible for having all the product inventory data. So there's too much data for us to actually put on one of these little devices. So there's going to be some kind of back-end server that our client application can make requests to get information about whatever goods the user has scanned, and that can be updated, whenever we want. Now, as it happens, I've implemented it with ASP.NET Core, but I didn't have to. I could have used any server-side technology we want for that, because Blazor as a client doesn't really care what your server is. But I'm kind of familiar with ASP.NET Core, so that's why I've chosen to do that. And then I've also got Blazor Client, and this is a Blazor WebAssembly application. And inside there, we've got basically the same stuff that we had in our other application, which was running on the server. So we've got the same kind of Razor files and C# files, and inside there, we're going to be doing the same component-oriented programming. So let's just try starting this up and see what it looks like before we look at some code. So if I launch that in my browser now, you'll see we get this Blazor Mart, and it's ready to go. So our user can now start using it. Now, if you remember, in the real world, the display will probably be sort of a portrait orientation, like this or something, but we don't really care about that. That's just a matter of CSS. So for the rest of this talk, we'll just continue displaying it full screen in landscape mode. And as you can see, the only feature of our application that we want to expose to users is the ability to scan groceries. Now, I've also got this autocomplete thing that I'll show you later, but we wouldn't have that in the real world. In the real world, users are just going to be using a barcode scanner. So to get a sense of what that's actually like, I've got a barcode scanner, and I've got some groceries, such as this tin of beans. So if I scan the barcode on this beans, you can see that immediately my application jumps into life, and it says, OK, you've scanned something. And it's started to work, but it's not really working correctly yet. You can see it says fake product instead of telling me what I actually scanned. So how does any of this work? Let's see some of the code that's behind there. And I'd say the best place to start with understanding this is this component that I've created called app.razor. That's my top-level root component in this application. And if we look in there, you'll see that we've got a series of other things. So up at the top, we've got this search box. That's obviously corresponds to the thing up there on the screen. And then below that, we're doing the same thing that we did in the budget example, where we're using a normal for each loop to say for each of the things in your cart, we're going to display this other component that I've created called cart row display. And then below that, if there's anything in your cart, we'll display a footer. So you may remember that initially there was nothing in my cart and I didn't have any footer on the screen. And so this if test was false. But when I come along and I scan something, then that test will become true and the item will become part of the UI. Okay, pretty straightforward stuff. But why does it say fake product? That doesn't really seem right. Well, let's see what the flow is when you scan an item. So our search box will raise this custom event or callback called item chosen, and I've wired that up here to this handle item chosen method. And down here you can see that, and it receives an EAN or EAM. And if you don't know what that is, well, neither did I until not long ago. EAN stands for European Article Number, and that is a standard thing in the retail industry, and it is literally just the number that's printed at the bottom of a barcode. So that's what the barcode scanner is providing to us here, and that's all we know about what they've scanned so far. And then we're going to try and add that to their cart. So I've factored out the logic for that into this domain type called cart, which is just a normal C# method, C# class. And if we have a look inside there, then let's see what that thing actually does. Okay, so you can see that I've got a little bit of business logic. It's kind of boring stuff, and I don't want to get into it too much. My logic is, if you've already got one of these in your cart, then we'll increase the quantity of it. And if you haven't, then we're going to start fetching it from the server, and you can see I've got this retry loop. We'll talk more about that later. The relevant bit right now is this bit. This is where we're going to actually fetch some data from the server. And as you can see, it's all very fake right now. So we're just waiting a little bit to pretend that we're doing some data access, and then we're returning this fake data. So how can we actually get real data from the backend server? Well, There's one very straightforward and obvious way, which is probably something that most of you have done, probably many times in your careers. If you want to get data from a server, there's a good chance that you would make an HTTP request to it and you would have it return some JSON data to you. And that's great. That absolutely works. It's very straightforward. It's by far the most common way of doing this kind of data access from a Blazor WebAssembly app or any other kind of SPA. And that's great. But there are some drawbacks to doing this kind of JSON over HTTP kind of approach to data access. One of the drawbacks is that JSON is not a very efficient way of representing data. It's a very verbose way of representing data that's designed for humans, and it's not even got all that much control over precision of certain things like numbers and dates and such. So it's not necessarily the most efficient way that we could represent our data on the wire. And the other thing is, when you make these requests, how do you know what URL to make the request to? And even if you know the URL, how do you know what HTTP method to use? And even if you know that, when the response comes back, do you know what the different status codes might be and what they're supposed to mean? Well, maybe you do, but it's quite a lot to manage, and there's no real formal system for tracking all this. It's kind of very much like an informal best efforts kind of system. So you might think, well, hasn't anybody invented a better way of doing this? Isn't there perhaps a more modern way of connecting my client and my backend server in a more performant and strongly typed way? And the answer to that is yeah, absolutely. There are loads of ways you can do that. Soap is one of them. Yeah, we could do soap. People have invented many different ways of doing that over the years. And one of them that has really started to get a lot of traction recently, can anyone guess what I'm going to say? gRPC, yeah. So the ASP.NET team did a lot of work in the 3.0 timeframe to make gRPC work really well on ASP.NET Core Server. And just in the last week, we've announced some experimental preview packages that give you support for gRPC Web. Now, gRPC Web is a subset or a slight variation on gRPC that you can use from browser-based applications. And I've got a browser-based application here, so how about we have a go at doing some gRPC from our client application? Okay, so how can we do that? Well, on the server, I've already got a little bit of gRPC stuff going on. If we look in this protos directory, you can see inventory.proto, and that's how we define a gRPC service. Proto is a language-independent format for describing a set of endpoints that can be called, and it's strongly typed, and it does some cool stuff for you. For example, you can automatically code generate code that can be run on the server and the client to wire all this stuff up together. Now, at the moment, I've only got one endpoint. It's called autocomplete, and that's the thing that is replying if I start typing into this box up here, so I can just, start adding stuff from the drop down. You wouldn't have that in the real world, but it's kind of helpful during development to be able to just type stuff and not use a barcode scanner all the time. Anyway, I want to get real product data from the server now. So I'm going to add a new endpoint on the server, and I'm going to define it like this. It's called product details. It will take a product details request and return a product details response. And I haven't defined those yet, so let's do that. My definition will look like this. The request will be the article number from the client, that's all. And then the response will be a product. Pretty straightforward stuff, okay? So let's build that now. And once I've done that, I can start filling in a server-side implementation for it. And like I said, this is designed to tie in with code generation. So on the server, you'll see I've got this class already called inventory service, which inherits from inventory base. And that is automatically provided for me by the tooling, which means now I've added that new endpoint, I can type override, and you'll see that IntelliSense says, hey, why don't you consider supplying some logic for product details? Okay, so I will. What logic do I want on the server? Well, I can do something pretty simple. I can do the following. I can say, okay, this is going to be async for a start. I'm going to add a bit of a delay because if I don't, it's all going to be too fast and you won't be able to see the loading states that we're going through. So we'll just do that. And then we'll do a lookup in the database to get the product object, and we can return that to the client. And that's all there is to it on the server. Great. So now I've changed my server. I'm going to have to restart that. And then I want to put some logic into the client to actually call it. And that's pretty straightforward too, because again, we are able to make use of this code generation stuff. So if I go into my cart data type here, my domain object, you'll see that in the constructor, I'm receiving from the dependency injection system an instance of inventory client, and that is code generated. I don't have to write that. And if I go down here, I can now call a method on it. So let's get rid of all this fake logic here, and we'll see what methods are on the inventory client. Well, you'll see that we've got autocomplete and autocomplete async, but what's happened to our product details? Why don't we have that? Surely we should by now. Well, I didn't recompile, so that hasn't been regenerated yet, but now I've recompiled, you'll see now we've got autocomplete and we've got product details, and we can call that from our client. So the logic we're going to want on the client looks a bit like this. We are going to construct a product details request with that article number. We will make it a request to the server, and we will get the product back out of the response. So let's see what happens now and whether this stuff actually works. So I'll come back over here, and I'm going to scan my beans again. And this time, what do we get? We get beans. So it actually works. We've got our server and our client talking gRPC together. And so my user can now go around and do the rest of their shopping. So in case you're wondering, I'm working on a bit of an experimental dessert recipe right now. So with my beans, I want to wrap them delicately in a parcel of ready-to-roll icing. And then to really bring out the flavors, I'm going to need a bit of this Thai fish sauce, which I think will go really well. But actually, I'm just going to need just a bit more of that to really, make the flavors pop. Okay, so we have been able to make our bigger application there speak gRPC between the client and the server. And we get some benefits from that, like we've got much more efficient network traffic now, and we get this strongly type interoperability between our server and our client. Excuse me. Okay, so let's move on from that to the next subject that I want to talk about. And this is going to be to do with testing, which is clearly a very important subject if you want to write some high-quality software. And one of our design goals for Blazor from the very beginning has been to make sure that you can test your Blazor components in a very productive and satisfying kind of way. So how could you do that? Well, traditionally, there's two main approaches that you could use for testing some kind of UI component. You could do unit-level testing, because Blazor components are just classes. So you could use a normal unit testing framework to new up an instance of your component and then start calling methods on it. And that's cool, but it's quite low level, and it doesn't give you any way of interacting with the rendered output. You can't say, I want to simulate clicking on a button or something, because there aren't even any buttons, so that doesn't. It's a very low-level way of doing testing. The other, more high-level way you could do it is to do some kind of browser automation using something like Selenium, which is something that we do a lot on the team that's building this because we need to check that the framework actually works. So we've got a lot of experience of setting up this very big suite of Selenium-based browser automation tests, and it's all very good in the sense that it's high-level, and you can work in terms of CSS selectors and clicking on buttons and things. But it does have the drawback that these tests tend to be quite slow to execute. It can take maybe a full second to execute each test, and unless you're very careful about how you do it, it's easy to fall into the trap of making tests that are a bit flaky because they accidentally depend on some details of the order in which things are rendered or the timings of things, and we've had to fight with that quite a lot. So this gets us thinking, can we design something that gives you a way of testing your components that has got the speed and robustness of unit tests combined with the kind of high-level expressiveness that you get with browser automation? So let's have a look at an experimental version of something like that. So I've got here this third project called blazormart.test, and I'm going to load that. And if we look in there, you'll see I've got this test class called cart tests, and it's going to be using XUnit as the test framework. And I'm also using this experimental thing called test host. And what that allows me to do is say, I want to mount an instance of my component in this test environment. It's not an actual browser, but we're going to be able to simulate what happens in terms of rendering and user interactions. Okay, so you'll remember this app component from earlier. App is the root component of my application, so I'm basically testing the whole thing. I could test individual components at once, or I can test complete groups of applications, just whatever level of the tree I choose to use as the entry point. So here I'm testing the whole thing, and I'm saying that if we look for all the elements with the cart item class, we won't find any, because by default the cart is empty, and that's what I'm testing here. Okay? The next test is a bit more detailed. This is going to test what happens when the user scans something. So just like before, we get an instance of our test component, our app component, and this time I'm going to do a bit of fancy mocking stuff, where I'm going to intercept any requests that are made to the back end so that I can simulate different kinds of responses coming back. Or in this case, I'm going to simulate there is no response that's come back. And then I want to simulate what happens when the user scans something. Now, if you were wondering how this barcode scanner actually works before, all it is it just simulates a keyboard. So if I scan these beans right now, then in my IDE, you'll see the number gets typed out like that. So that's all the barcode scanner is doing, and I can simulate that same action by typing into this search input a fake EAN. Okay, then I submit the form just by pressing enter like the barcode scanner does. And then I can say, okay, if we look for the cart items now, it's not going to be empty anymore. There will be one, and it will say loading on it. Okay, that sounds believable, right? And then thirdly and finally, we can test what will happen when the server replies. So I'm in the same situation as before, except this time I'm going to simulate the server replying with this particular data. And now I can check that inside the UI, that particular product name has shown up on a certain element in the rendered output. Okay, so let's see if this stuff actually works, shall we? These are standard .NET unit tests, so they will run in any .NET test runner. For example, you can run them inside the test runner that's built into VS or on the command line, whatever you like. And I'm running them now. It has to compile, and then it runs, and you can see that they've all passed. And the nice thing about this is that it's very fast. So the first one might take a little while to get started up because, you know, it's still jitting and all that. But once it gets going, they're really, really fast. So we're talking single-digit milliseconds here. And it's going to be very robust because there's no out-of-process activity at all. It's all completely synchronous in process. You shouldn't get flaky behaviors. Okay, so that's nice. But can we use this to actually aid our development process in any practical way? For example, does this mean that we can now do test-driven development? Well, I'm not claiming that you always should do test-driven development or necessarily that you even ever should. I'm not giving you any opinion about that right now. All I'm saying is, if you did want to do that sort of thing, then hopefully the tooling and the platform and all the libraries that we give into you should support whatever workflow you want. So let's imagine that we do want to do a bit of test-driven development right now. And the feature I want to add is this one, this remove item button. You'll notice that if I click this button right now, I'm clicking it, nothing happens at all because I haven't implemented anything just yet. So what behavior would we want to have? Well, the UX that I want around removing is if the user wants to remove an item, I don't want them to be able to just pick from the screen which item they're removing. Because if they do that, they might make a mistake and remove the wrong item, and then they'll get completely confused and they'll just have a disaster in the shop. So what I want them to do instead is when they say they want to remove stuff, I want them to have to scan the item that they're taking out of their trolley. So, you know, the CCTV people can watch and see that they scan and then they put it back, and they really did actually put it back. Yeah. That's how it actually works in the shops as well. So I want, when I click on the remove item button, for the whole UI to switch into a different mode, which is about removing stuff now, and then they scan and then it will switch back into the normal mode. So that's quite a complicated UX flow there. And since that's a bit complicated, I'm going to feel better if I can define that using tests. So I'm going to start by defining another test just now, and it's going to be called canRemoveItem. And for this test, again, we'll simulate being in this situation where there's an item in the cart. And then I'm going to write some assertions. So I'm going to say that by default, there won't be any overlay covering the screen. Because how I'm going to implement this is, when you go into this remove mode, there's going to be an overlay that fills the whole screen and displays a message. But we're not in that mode by default, so that should be null. And if we run this test now, should it pass? Any opinions? Quick? No? Yes. People say yes, and they are right, because there is no overlay by default. I haven't implemented that, so it's going to pass. Okay, so following this test-driven kind of process, I'm going to add some more assertions until they start failing. So this time, I'm going to simulate clicking on the remove item button, and now this overlay should not be null anymore. It should be there. It should be on the screen, and there should be some text in it that says scan an item to remove. And if I run the test again now, well, this time we don't expect it to pass because we certainly haven't implemented any of that stuff just yet. So this time when it runs, the test fails. And does it give us a good explanation? Well, it says the element does not have an event handler for the event on click. Okay, and the actual line of code that is throwing that is this one here. So you can see it makes sense, right? You're trying to click on this item, but that item doesn't even listen for clicks. So it makes no sense, and we're just going to fail the test. So I'm going to go over now to this remove item button, and I'm going to put in an actual click handler. So I'm going to use @onClick because the handler is going to be a .NET handler and not like that, which would be a JavaScript one. And inside there, I'm going to say, let's call a method called enter remove mode. All right. Now I'm going to have to define that method, otherwise the IDE and the compiler will start complaining at me, as you can see. Look, that doesn't exist. So let's define this method. And what is it going to do? Well, it's going to do a pretty simple thing. I'm just going to set a flag to true, and I haven't actually defined that flag yet, so let's do that. Okay. And that's all for now. Let's see if our test starts passing. So we'll run the test again, and this time we know there is a click handler, so it shouldn't fail for the same reason, at least. And this time, does it pass? No, it still fails, and this time it says there was a not null assertion failure on this line here. So again, it makes sense. The overlay did not appear, so the test should fail. All right, let's make the overlay appear this time. So again, using normal Razor syntax, I'm going to say, if we're in the remove mode, I'm going to display an overlay with this markup inside it. Now, if you are wondering what overlay is, like, is this a built-in framework feature? No, it is not. It's a very simple component that I've put in my application here called overlay, and it just renders this div with this class of overlay, and it puts whatever child content inside that you want. And in this case, the content I want is this paragraph here. So let's try running our test yet again. Will it pass this time? Well, let's see. After it recompiles, then this time, it does pass. Good. All right, great. So we're making some progress. But this is not the whole flow that I want to test. I want to test what happens now if we scan an item while we're in the remove mode. So let's add a little bit of logic for that. I'm going to say, all right, I'll simulate the barcode scanner in the same way that I did before, scanning the same item that we've got in the cart. And this time we should say that the cart has now become empty because we removed the thing for it. And then the overlay should go away as well. Let's run the test yet again and see whether it passes now. Of course, it should not, because we haven't implemented the actual removal feature, so it doesn't. So let's implement that right now. How's that going to work? Well, I'm going to change my handle item chosen a little bit. I'll say if in remove mode is in remove mode, then we'll do something. And if we're not, then we'll do what we were doing before. And the logic I'm going to have now is cart.remove item, and we'll pass that article number through to there. And we can say then the is in remove mode can go back to being false so that we're not in that mode anymore. Okay, so as far as I'm aware, we've now implemented this feature correctly. So let's try that out and see if our test is any happier this time. And the answer is that the test passes. Great. So we've now implemented this remove feature, and we know it works because the unit test says so. We don't even need to look at it in a browser because we have that much confidence, right? No, I actually do want to see it. I'm sure you want to see it as well. So let's try it now. Let's say I've got some beans and some fish sauce. Then, oh, I've killed my web server, so that's not so good, is it? Let's bring that back up. So up you come. And now I'm going to scan my things again. There and there. And I've decided that I don't really need those beans because Thai fish sauce is nutritious enough on its own. So we'll get rid of the beans, and you can see it actually works. So excellent. All right, so that is about testing. And there's a third area that I want to go on to now. So another area that we haven't actually shipped anything useful for, but we are planning to do so by the time this stuff ships, which won't be too long, is around progressive web applications, or PWAs. So that's a pretty hot area in the front-end world at the moment, has been for a year or two. And these PWA APIs are ways of doing desktop-like things from inside a web browser. And the most famous thing that you can do with the PWA APIs is make your application work offline. That's kind of the headline feature for PWAs in general. And that would actually be really useful for us with this application, because how do these devices work anyway? Well, presumably, they work by connecting to the in-store Wi-Fi. So Wi-Fi is not 100% reliable. What happens if a shopper comes into the shop, they pick up one of these devices, and they're about to start using it, but at that very moment, it can't connect to the Wi-Fi? What's the user experience going to be like? in that case? Well, we can find out, we can simulate it. So I'm going to tell my browser to simulate being offline, and we'll see what the user experience for our shopper is now. It's now, not a great user experience, I think you'll agree. So can we do a little bit better than that? Can we work offline? Well, yes, that's what our PWA APIs are going to let us do. And the point of me showing you this is really just because Blazor is a standard, it's just using standard web technologies. There's nothing special or dependent on a server with it. You can use all the same PWA features that you would from any other front-end application. So if we want to work offline, we can use something called a service worker. It's a standard JavaScript API. And I've already got this service worker file in my project here. So that's a big chunk of JavaScript. And you might be thinking, hang on a minute. This is meant to be a .NET thing, is it? Why are you now showing me this massive block of JavaScript? I don't want to see that. Well, I can sympathize with that to some extent. There's a good reason why the service worker is best to write in JavaScript and not in .NET. And that's because a service worker runs in a completely separate context to your application. It's not running as part of your page at all. So even though your page normally has a .NET runtime inside it, the service worker does not. Theoretically, you could load up a .NET runtime inside a service worker if you wanted, but honestly, this is 40 lines of code. Is that too much? And the other thing is, you don't really even have to write these things yourself, because service workers are very boilerplatey kind of things. So if you go online and you do a web search for service worker cookbook, service worker boilerplate, that kind of thing, you'll find lots of examples of standard service workers that other people have written that do standard things like making your application work offline. So that's what I've done here. I've got this pretty much boilerplate service worker, and I want to add a reference to it in my application. And the way you do that is with a little bit of markup in your host page. So I'm going to say, okay, browser, I want you to use the service worker APIs to register this service worker here. And now we've done that, if we look in the browser console and reload, you'll see it now says installing service worker. And that code is now going to run in a separate context from our page, and in fact the browser will use it whenever it's trying to make any network requests to our domain. So if I hit reload, you'll see every time there's a request to my domain now, we get these little messages because I've put some logging inside that service worker just to say we can see that we're trying to make this request. And because that service worker contains the logic to work offline, to cache all this stuff and replay it if you can't reach the network, let's see what happens now if we are actually offline. So I'll press this offline button again, and I'll hit reload. And this time, we do not get the error message. In fact, the application just comes up and it works absolutely fine. So that's pretty cool. Or is it? Well, some of you may be thinking, so Steve, you think you're very clever, don't you, making your application work offline? But you're not clever. In fact, what you've done is stupid and pointless, because what's going to happen now? The user's going to start walking around the shop and they'll start scanning groceries, and what's going to happen? Because you can't reach the server, can you? Okay. I accept that is a valid point. So what's actually going to happen in reality? So the user's going to go around and they're going to start scanning stuff. So I'll scan these beans, and you can see we cannot reach the server anymore. So that's sad, boohoo. But the good news is we're still running all of our arbitrary application logic here, even though we're offline. We're still running our .NET code. And because there's a little bit of retry logic in there, if the user later walks into an area of the shop where they do have Wi-Fi access, then even without having to scan their stuff again, you'll see that it recovers and it fills in the cart and completes the operation correctly. So we haven't achieved a miracle there. We weren't able to reach the server even while we were offline, but we have been able to make ourselves reasonably resilient to certain kinds of network outages, which is the best I think that you could realistically hope to do. So that's pretty nice. Okay. What else can we do with these PWA APIs? Well, the other most famous thing that you can do with them is you can make your application installable. So instead of accessing it through a browser, the user can access it as if it was a natively installed app on their Windows Start menu, their Mac dock, or their iPhone or Android home screens. And that's just a standard feature that browsers and operating systems provide to us. So that's pretty good for us, because when our customers, our shoppers, are using this app, we don't want them to think they're using a web browser. We don't want them to see an address bar, because they'll probably just start using it for something totally unrelated. So we want it to feel like a native app of its own. So I'm going to do that with one of these manifest files. Standard PWA feature. I'll give my application a name, define an icon and some colors and stuff, and then I'm going to register that in my index.html page. So I'm going to use one of these link tags like that, and we'll see now what effect that has on the application. So just before I reload, I want you to watch carefully. See these two icons up here? Well, when I reload, there's going to be a third one. So I hit reload, and you can see this little plus thing has appeared now. And if you click on that, it prompts us, do we want to install this into the operating system? And I'm going to say, yep, I sure do. And that's now going to pop up with its own window. It doesn't have a browser address bar. It's got its own color themes and everything. And it is a real application. It's our same application as before. And the user now, if they want to, can find it from their start menu like that. And that'll come up on its own. And, you know, it really does work. It has all the functionality that we had before. So that's pretty nice. So that is all I'm going to have time to tell you about when it comes to this Blazor Mart thing. So we've been seeing how we can use some of these things that we haven't actually shipped yet to take a Blazor WebAssembly application and make it do cooler stuff than you would normally be able to do. Okay, so let's now, for the rest of the talk, try and broaden our minds a few notches further. Because so far, I've only really told you about a couple of things, and there's actually a much bigger and more exciting world out there. So, do you remember back in the day when we had this slide earlier on in the talk? Okay, so I said that I would talk to you about the differences between these two models and when you can use them. Well, the first question is, have these things even shipped yet? Are these supported products? Well, the answer to that is that for server-side Blazor, yes, that has shipped. That shipped as part of .NET Core 3.0, which was out in September, October-ish last year. So this has been a shipped, supported product for about 4 months now. So yes, that is absolutely a fully supported thing. For client-side Blazor WebAssembly, that is currently still in preview. And I know it's been in preview for absolutely ages. And yes, we desperately want to actually ship this. We finally got an actual committed release date. It's not very far away from now. It's in May this year. So just a few more months to go until that is shipped and supported as well. Okay. So the next question to ask is, which of these two models is actually the right one for your situation? And before I answer that, I just want to really emphasize this key point that you've got to get into your mind, which is, it's not really an either-or situation. It's the same programming model that's going to work in both environments. So if you buy into the idea of building a Blazor UI, then you can choose to run it on the server, or you can choose to run it on the client. You can start on the server and move to the client. You can start on the client and move to the server. You can even, in some crazy advanced cases, create an application that does both at once if you want to. So that's the flexibility that you're getting by buying into this pattern. But still, the question is, which one still is the one that you would actually want to use? Well, it depends on your situation, obviously. So when it comes to server-side Blazor, that's going to be the best choice for you if your users have got a reliable low latency connection to your server. And the reason why it's going to be the best in that case is because it's much, much simpler. You don't have to actually send the .NET runtime into the browser. You don't have to send your own code into the browser. Everything's running on the server in a much more predictable and controlled environment, and the UI updates are just being streamed over the wire down into the browser. So that's a very straightforward solution for you, and it means that you can work with very low-powered devices because they're not really doing any significant work. So that's nice. On the other hand, the best situation for doing client-side Blazor WebAssembly is going to be in cases where you want to not rely on access to the server. So if you want to actually work offline, then you absolutely need to be running on WebAssembly because there's no server in that case. Or if you need to have incredibly fast, fine-grained UI updates, then Blazor WebAssembly is going to be the best choice for you there as well, because you don't have to wait for any network traffic in order to update the UI. And the other cool thing about Blazor on WebAssembly is to do with hosting. So when you publish your WebAssembly app, there is no specific server requirement. It's just a set of static files as far as your server is concerned. So you don't need .NET on the server. You don't need anything in particular on the server. You just need to be able to serve files. So you could host it on something like a CDN or a blob store or anything else like that. And to prove that to you, let me show you in my browser now. If I load this bookmark, Blazor Mart Live, you'll see that actually opens my site just like before, and it works just like before. But have a look at the URL there. You'll see that this has actually been hosted on GitHub Pages, which, as you can understand, is a very, very cheap way of hosting your application. It's free, it's globally distributed, and a Blazor WebAssembly application can be served from that just like it can be served from anywhere else. So that's one of the cool things. Okay. Now, so far, I've only talked to you about ways of running your application inside a browser. But Blazor is a more flexible programming model than just that. You can run it in other places too. What if you didn't want to make something that people load in their browser, you don't want to be subject to normal browser sandbox limitations, but you actually want to make a native application running regular native code and have that pop up on a user's desktop? For example, you might want to build something like an Electron application with Blazor. Well, we've been doing quite a bit of experimentation with that recently, and we've got some samples for you to try out if you're interested. So we've got a sample of doing Blazor with Electron. We've got a sample of something called Web Window, which is like a very lightweight alternative to Electron. It's very experimental, but it doesn't involve bundling a browser, it doesn't involve bundling Node, so it's a much more lightweight way of bringing up a desktop application that contains a Blazor UI if you want. So see those samples if you want. And then in this bottom right corner, there's something even more future and elaborate, and we haven't really even done it yet, but I want to talk about it anyway. So what if we don't want to use web-based rendering technology at all? We don't want to use HTML and CSS. What if we wanted to make a native mobile application for iOS or Android, or even a native desktop application, and instead of rendering through web technologies, we want to render native OS components? Well, we've got a sample of that as well. And just to really emphasize, neither the hybrid nor the native options are committed products yet. These are just experiments, but we do really want to get your feedback about whether these things should be made into real products. And I want to show you an example of something called Mobile Blazor Bindings, which is a collaboration between the Xamarin team, who mostly did the work, and the Blazor team, who just get to take credit. And I'll show you how we can use it to build a native iOS application using Blazor as a programming model. So let's switch back into the IDE for the last time now, and I'm going to load something called Blazor Mobile App, which is not the most creative name. And inside there, you'll see I've got 3 projects. I've got Blazor Mobile App, which is a Blazor application, so it contains a bunch of Razor files and C# files, and it's the same programming model that you know and love by now. And we've also got Android and iOS projects. There isn't really any significant amount of code in those 2 at the bottom. They're just little shell wrapper applications that know how to start up on each of those 2 operating systems. And I'm going to use the iOS one right now. So I'll show you the code in a minute, but first I want to show you the app actually running. So all being well, I'm going to be able to make my phone screen appear in front of you all just now. Let's see if this works. Okay, yeah, very good. Okay, so this is a iPhone, a normal iPhone, you know them, does all the normal iPhone-y things. And I've built this application here and deployed it onto my phone. So if I start that up, when that comes up, that is not running inside a browser. There's no WK Web View or any other kind of browser rendering technology. This is native iOS elements. And we've got all the usual kind of demo things in here. So I've got this button, I can tap on it and it says how many times I've clicked it. I can move on to the to-do list, we'll do that in a minute. And we've got calculator. So that's all just being rendered using Blazor components, and it works. Cool. What about this to-do list? Well, it's just, you know, the usual industry standard to-do list that we always have to show. Let's add some stuff to the list, so we'll have stuff. Okay, and I'm going to tap on this add button. What will it do? Oh, what a shocker, what a disappointment. We haven't yet implemented the add item feature, which means we're going to have to implement it just now as a demo. Okay, so let's have a look at some of the code in this application. Well, let's start with this counter right here. Now, if you are familiar with the Blazor programming model, this should look pretty familiar to you. This is pretty much the same as the web-based counter with one kind of important difference. So inside the code block here, we've got exactly the same code as normal, just normal C# code that's got a count and an increment count button. And above that, we've got markup, but it's not HTML this time. And in fact, I cannot use HTML even if I wanted to, because there is no browser here. The only thing I can use are these native iOS elements. And the ones I'm using are this stack layout, this label, and a button. So we've got a label that says how many times you've clicked, and a button that when you click it, it calls increment count. And that behaves in exactly the way that you think it should. Okay, and what about the to-do list? Well, there's a bit more going on with this one. Let's just go through it step by step. Okay, so to get started with, we've got this to-do item class here with the usual is done and text properties on it. We've got a list of to-do items, and we've got a new text string where the user can enter some new text. And up at the top here, we've got this entry, which is the thing that the Xamarin team uses to mean text box, and we've bound that to this new text field there. And then I've got a button that says, when you click it, we'll call add item. And inside on add item, we're rendering this little pop-up message. So let's fill in an actual implementation there. So I'm going to say to-do items.add new to-do item, and we'll set the text on there to be the new text. Okay. And then I want the text box to get cleared out. So I'm going to say new text goes back to being its default value of null. Okay. I also need to actually display these items. And because this is not XAML, I don't have to do any complicated stuff with bindings or whatever. If I want to iterate over things and make a list, well, I just go for each with normal C# syntax. For each item in to-do items, I'm going to render a to-do list item. And the thing that I'm going to pass to that is the item. Okay. Very good. So that's pretty much all I have to do, but I'm just going to do one more thing because I like to. I'm going to also display the number of items that have not been completed yet. So I'm going to say, we'll get your to-do items and we'll count all the ones in it for which the isDone property is still false. Okay. Now let's try compiling that now, and we'll see if that actually builds, and hopefully it will. It does, okay. Now I've also got that version of it on my phone as well. So I'm going to start that up and we'll see what happens now. So if I go into this to-do list now and I start entering something, this time when I tap on the add button, you'll see it does actually show up in my list. And I can do more things. Let's have Blazor let's just do this. Third day, you get to go to the lobby. Okay, cool. That makes total sense to me. Don't know about you. And then I can start toggling these buttons and it all works. You see the number updates as I do that, and we have all the usual scrolling and stuff. So we've been able to create a native feeling iOS application using the Blazor programming model and without having to use any sort of web rendering technology. Okay, so that is it. That's all we have time for today. So I hope some of that has been interesting and useful for you. If you want to learn more about this stuff, if you want to learn more about Blazor, then go to blazor.net. If you want the code and the slides from this talk, then go to the URL that's up there, and you can download that and see that for yourself. So I hope that's been fun, and I hope you have a really good rest of the conference. Thank you for coming.